Hello, my name is Dmitry Gorsky. I am the CTO of Heave Solutions, and welcome to this third webinar in our Surge and Swab series. Today we're going to talk about how to utilize Surge and Swab simulations in practice. So how to get the upside from the menu drilling and well operations. And just to remind you, we are a specialist consulting company based in Norway, and we're really good at telling you what the end of your completion string or drill string or liner casing is doing in relation to the rig. And this is our know-how, and this is actually the tricky part, to relate the movement of the rig or top drive to the movement of the BHA or the end of the string. And this is because there's a lot of factors influencing this. There is the elasticity in the drill string or completion string or liner. There's the friction between the well and the completion string. There's the non-Newtonian character of the fluids and so on. So let's take a look at our method and our technology. So the simulations we start with are Surge and Swab on connections. So we simulate a lot of time series for every connection down along the well trajectory. So every time you set slips, we're doing a simulation where we're deciding how much surge and swab you have in relation to the movement of the rig, so the rig heave, and also during tripping, we do the same thing. And normally, you start with a mud weight line and lower limit for your well pressure. Usually is the pore pressure, or it can be the well collapse pressure too. And there is an upper limit too. So most often it's a frac pressure. But in reality, this is not the whole truth, because every time you make a connection on a floater, you set slips, there will be pressure variations downhole influencing this mud weight line. And let's look now at a connection done at 4,500 meters in this well. So we've drilled this well down to 4,500 meters, we picked off bottom, and then we're doing a connection. And this is how it's actually going to look like with the rig heave we've simulated here. There will be surge and swab propagating all the way down up in the well from the point where you make the connection. And the question is then when it intersects the well pressure margins and also where it intersects the margins. And here you can see that there is this point up at around 3,200 meters where the geology makes the pore pressure or wellbore collapse higher. And then there's of course the point where the connection is made. So this is how it looks like in reality and in our simulations. And then we have to relate this to something. So one way we've already seen is to relate the surge and swab to the well pressure margins. This is the most common situation. You'll see this during drilling. You will see this when running liner or casing, and also running a lower completion string. When the reservoir exposed, this is what you will get. But of course, sometimes there are some special situations. For example, when you are running an upper completion string and your reservoir is already isolated with a plug, the limitations for surge and swab will actually be the limits of tools in the drilling completion string. So often tools such as packers have their limits. They're decided by the annulus flow past the packers. It can be liner hangers and so on. And what you risk if you exceed this flow in annulus past the packer is that you preset the upper completion string. And there is there you can also calculate this limit. So how much rig heave required to preset the completion string, and this will be your rig heave. So how do we do it from that point when you have a lot of simulations of rig heave-induced surge and swab during connections? Well, we take each connection and then we start with quite mellow conditions, maybe even flat C. You see it to the left here, and then we model increasing the rig heave, so going to higher and higher waves. And we do this modeling of higher and higher rig heave until we see that the surge and swab down in the well interferes with one of the well pressure margins. So this is what's illustrated in this graph to the left. You have simulations with increasing surge and swab, which start at the mud weight line, and then when the surge and swab in this case intersects with a lower pressure margin, this is what your rig heave is at that depth. And to the right, you can see a couple of examples of what we call a dynamic rig heave. So a rig heave which we calculated for different depths along the well trajectory. And as you can see, this rig heave is very different at different depths. And you can also see that it's very different for different operations. So the graph to the left, for example, is your dynamic rig heave for drilling of 8.5 inch section. And to the right, this graph is your rig heave limit when running upper completion. And this is a kind of a graph you can use directly in your drilling and well operations. You can include it in the DOP or completion manual. You can communicate it very easily to the rig, and so that driller and the drilling supervisor on the rig will always know how much rig heave the well can take during next connection. And as you know, the rig heave is something that's forecasted a couple of days ahead. So this can also be used for planning the operations ahead. So looking at tomorrow or the day after tomorrow and using this to plan your completion operations, for example, or when you can restart your drilling operations after a storm has hit you and you had to abort drilling. So decisions like this. And there are other features and capabilities of our software as well. It's very precise. So here to the left, for example, you can see a calculation of dynamic rig heave. So how much rig heave your well can take at different depths for running a completion with closed tailpipe and open tailpipe. And there is a difference in how much rig heave your well can take, because then there is less volume with a closed tailpipe being able to take up those pressure fluctuations. And down at the left corner of this graph, you can see a point called TRSV closed. And this is a simulation we've done for testing of the TRSV, where you have to set slips for 1 or 2 hours, and the completion string will then be moving together with the rig. And the rig heave limit there is a bit lower because the TRSV is closed. There's even a bit less volume available. So the simulations are very, very accurate. And this is a recommendation on the running speeds without heave compensation. So this is when your rig is not equipped with a heave compensator, or if you choose for some reason to trip using elevators, so without any heave compensation. And there, the surge and swab effect from the moving rig, it's overlaid on the tripping speed. So then, when the rig is on the way down, you're going to be moving a little bit faster, and when the rig is on the way up, it's going to be a little bit slower. So as you can see there, at calm seas, the rig heave limit is highest, and then when the waves pick up, the rig heave limits become lower and lower. So thank you. This was about our method and technology for using our surge and swab simulations in practice. And the next webinar, or 2 webinars, will be case studies from our clients. So I will see you then. Thank you.